sorry, the decomposition of hydrogen peroxide to produce water and oxygen gas can be investigated using the following apparatus. So basically you are having hydrogen peroxide and you are decomposing it, yeah, so it will give you water and oxygen gas. Okay, so which apparatus is used for this reaction? So if you want to see, in terms of oxygen is given off, for example, okay, of course you need to use gas syringe. Okay, so you need to collect, okay, using gas syringe. Now, apart from that, okay, is there any other thing that you need to use? Do you need to use the balance? Okay, so they say, okay, hydrogen peroxide. Okay, hydrogen peroxide is generally liquid. Okay, so if you want to use balance, I don't think so. Yeah, if you are using crucible, okay, I don't think so. You need to actually use crucible as well. What is crucible? Basically, when you heat up certain thing, okay, and you want to remove water, okay, you can use that. But normally inside the crucible, we will use the solid. We will put the solid inside. Okay, so in this case, okay, the answer, I think the best, okay, is going to be A. Okay, so A will be the answer. Now next, okay, so we do together, yeah. So number 2, which separation method would give pure samples of both substances from the mixture? Okay, so we want pure samples, yeah. So if you want, let's say for example, copper sulfate crystal and water, okay, can you use filtration method? Can, yeah. Copper sulfate crystal and water. Copper sulfate crystal, when you add water, they will dissolve. Okay, they will dissolve. Copper sulfate is blue in color crystal. When you add water, they will dissolve to give you blue solution. So when you want to filter, you cannot do filtration. Okay, so you cannot use this method. So if you want to separate ethanol and water, can you use simple distillation? Possible, yeah. So let's not say maybe must use fractional distillation, possible. Okay, but the best method is of course fractional distillation, yeah, because water and ethanol, okay, the boiling point, they are almost similar, yeah. So let's keep it first. Okay, let's look at other type of separation. Salt and sand. Okay, and you want to use magnetic separation? No, definitely no. Yeah. So oil and water, and you want to do crystallization? Definitely no. When do we use crystallization method? So for separating something that can be crystallized. How do you know which one can be crystallized? For your syllabus, just remember copper sulfate. Yeah, copper sulfate, they can be crystallized. Okay, so other like oil, water, all this, you cannot actually separate them using crystallization. How do you separate oil and water? How do you separate oil and water? What thingy? Maybe we can, I do not know the actual term for it. Yeah, so there is going to be, when you add oil and water, they will form 2 layers. Okay, separating funnel, correct. Yeah, there will be 2 layers, and then you can separate the one at the bottom. Okay, separating funnel has some sort of extension like a pipe. Okay, so they can collect the water out, leaving the oil, the top layer on the top. Okay, so you can use separating funnel. Now, how do you separate? Okay, how do you separate other than using filtration? How do you separate? Okay, let's say for example, you have something that is insoluble. Okay, example, let's say silver bromide. Okay, silver bromide. Okay, silver bromide or silver iodide. Let's make it silver iodide. Silver iodide, okay, is insoluble. And then when I put, okay, silver iodide, okay, I just put over here, silver iodide, okay, what happened over there? Okay, let me see. It's reconnecting. But anyway, you just listen to me, yeah? So let's say, for example, if I have silver iodide, and then I am putting water inside, and we know silver iodide, they do not dissolve in water. How do I separate silver iodide and water? Silver iodide maybe, even though it's actually insoluble, but it's in powder form, for example. So how do I actually separate silver iodide and water? Any? Yeah? Crystallization, no. Yes? Yeah, possible. You can use evaporation method. Yeah? Another method starts with D. Yeah? Starts with D, letter D. Yeah? Love letter. Last letter, yeah? Okay, N. No.
Decomposition.
No. Decomposition is not even separation technique. Okay, how do you actually separate? You can use decantation. Okay, decantation. What is decantation? What is decantation? It's like if you have something, okay, and then water, okay, you just take out the solution slowly, you just pour it out, okay. So the connection is a bit slow, yeah. So you can see if you have something, let's say like this, you pour this out, okay, slowly, so that leaving this insoluble stuff aside, okay, still inside, you take it out. So this is what we call as decantation, okay. Like for example, let's say, you know, the traditional way of making tea, yeah, they use the tea leaves and so on, okay. So you can, of course, the best way is by using the instrument. I do not know what is the instrument's name, yeah, but if you let it sit for a while, okay, all the tea leaves, okay, the grinded tea leaves will be at the bottom. So you can slowly use the decantation method, and then you can try to remove the solution and leaving the one that you don't want, okay, at the bottom. Or simple way, if those people who drink kopi kapal api or something like that, sometimes you have the last part over there. So let's say you don't want to, of course we don't drink the last part over there, so we can do the decantation, yeah, and remove the part that we don't want to drink. Yeah, that is how you separate. So it's called decantation. Okay, decantation. So please take note of this. Yeah. So anyways, the answer for this is B. Yeah. Now, next question. The diagram shows the arrangement of particles in 3 different physical states of substance Q. So which statement about the physical states of substance Q is correct? Okay. So substance particle in state 1 vibrate in fixed position. Is that correct? No. Number 1 most likely is going to be under what state? Liquid. Okay. So the one that vibrating in a fixed position supposed to be solid. Yeah. So this one is wrong. Number 1. Okay. State 1 changes to state 2 by melting. So it means liquid changing into gas. Melting? No. It can be either what? Evaporation or boiling. Yeah. So that is wrong. State 2 changes directly to state 3. State 2 changes directly to stage 3. It means now gas changing into solid directly. So what type of changes is that? Okay, is it condensation? No. What is the change? Sublimation. Do remember, gas to solid, solid to gas, we use the term sublimation. Okay, so this one is also wrong. Now, the substance in state 1 has fixed volume. Yes, water is liquid. Water will have fixed volume. Yeah, But the one that is having not fixed volume, not fixed volume will be gas. Although liquid can be compressed, okay, it cannot be really compressed that much. So the volume will be fixed. Solid, the volume will be fixed. Okay, but gas, the volume is not fixed because it will follow the volume of the container. So that is going to be, okay, in this case, number D is correct. Okay, next. Number 4, a gas is released, okay, at point P in the apparatus shown. Okay, so we don't know what gas is that. Okay, so which gas turns the universal indicator paper blue? I told you, universal indicator. Okay, universal indicator. Just remember, blue means alkali, red means it's going to be acid. Okay, so we want to see the indicator to change into blue. Okay, so it means it must be alkali. Which of these following gases are going to be alkali? So the answer is going to be, let's explore one by one. Sulfur dioxide is acidic. Okay, why? Sulfur is non-metal. Okay, non-metal oxide, they are acidic. Remember the last chapter that we did. And then carbon dioxide is also acidic. Okay, please remember that carbon dioxide is acidic. Okay, this is going to be basic. Okay, ammonia is always basic. What is going to be other indication for ammonia? Pungent smelling gas. Very good. Pungent smelling gas. Okay, CH4 is neutral. Okay, they do not change any indicator color. Similar to another particular gas that is neutral in your syllabus in the textbook, CO, carbon monoxide. Carbon monoxide. There are other gases, oxygen, neutral. Okay, but in your book, okay, they mention methane and carbon monoxide. Now, I just want to ask you another one more question. How about chlorine gas? Chlorine gas, acidic, basic? If you are having doubts, always refer to what I mentioned to you just now. Cl2, it's going to be towards the, although it's not oxide, but it's going towards to the non-metal. Okay, so Cl2 is acidic. But when you go and test with litmus paper, okay, you will not see the color from blue to red or even red to blue because Cl2, okay, they will bleach the litmus paper. Okay, even though it's acidic, okay, bleach, okay, the color will be removed. Let it be blue litmus paper or let it be red litmus paper, the color will be automatically removed. Now, okay, just hold on. Why the seating arrangement is not being followed? Already changed again? Okay, but I still want Max to come here.
Max is supposed to be.
Yes. Okay, now, so this is neutral. Okay, so which gas turns the universal indicator blue most quickly? Okay, there is only one, okay, which is going to be C. Okay, the sulfur dioxide and carbon dioxide, they will not change it to blue. So I think the question is also not so clear. Okay, there is only one particular gas that can change it into blue. So the answer is going to be ammonia. Okay, pungent smelling gas. Okay, and so on. Now, always remember the term pungent smelling gas is not limited to ammonia only. Within this list of 4 gases, there is another one more gas apart from ammonia that is also being described as pungent. Do you know which one? What is the meaning of pungent? Ammonia, the term pungent, okay, is normally referred to the smell of urinal that is not being cleaned for some time. Yeah, so that's pungent. But actually, the term pungent is being used as a sharp smell that will make you don't want to smell it anymore. Yeah, that is the term. Okay, so pungent can be also be used for SO2. Okay, SO2 is also being described as pungent gas as well. Yeah, although the smell is different. Yeah, but it's going to be a smell that is very sharp, that makes you don't want to go close to it. Yeah, so that is SO2. Okay, so pungent. So we don't use the term pungent, okay, and just to confirm, oh, this gas is pungent, therefore this is ammonia. No, we don't do that. Okay, we say, okay, pungent gas, we still need to test, okay, with litmus paper, okay, the red litmus paper, and that red litmus paper must be moist. Yeah, must be moist, because okay, if it is moist only, it can help gas, especially gas. If you want to test whether they are acidic or basic, you must make sure the litmus paper is moist. Yeah. So next, okay, impurities, okay, will change the boiling point and melting point of a substance. I hope you remember this. We did one particular class, okay, about this. Okay, one particular. I think if you remember, something to do with the fish, and then you put the dust powder or something like that. Yeah. So anyways, impurities will change the boiling point and melting point of a substance. To test a student, a teacher covered the numbers on the thermometer and asked the student to record the boiling point of water after the impurities is being added. Okay, the diagram represents part of the stem of the thermometer. What could be the temperature reading on the thermometer? Yeah, so let's see. Okay, now first of all, water. Okay, the boiling point is going to be, generally pure water is going to be 100. Okay, the melting point is going to be 0. Okay, 0 and 100. But when there is impurity, what will happen to the boiling point? Decrease or increase? Yeah? You're telling increase or decrease? Okay, Naomi is telling increase. You are telling increase also. Okay. So boiling point is increasing. How about melting point? Decrease. Yeah. So please go and read about this. Okay. Why the boiling point is going to increase? Okay, because the impurities, okay, they are going to prevent the gas to escape to the environment. Okay, so it means it will be taking the boiling point will be slightly higher. Yeah, will be slightly higher. Okay, and then the melting point will be lower. Okay, so in this case, it should be greater than 100. So what is going to be the answer over here? 105 or 105.5? So if this one is going to be, if you take it over here, okay, so what is this? 1, 2, 3, 4, 5. Okay, so this is 100. So this one will be 105. This should be 106, 7, 8, 9, 110. Yeah. So it ends over here. Okay, should be 105.5. Yeah. I hope this is clear. Yeah. So 105.5. Some of you might be asking, sir, how do you know this is 100? Why this one cannot be 100? Okay, if it become 100, there is no answer. Yeah. So why? Because if this one is 100, then this one will be what? 100. So this one will be 100. This one will be 110. Okay. So this one will be 100. How many? 120. Yeah. If you follow that. Yeah. 120. There is no answer as 120 over here. Yeah. So this has to be 100. Now number 6. So for number 6, solid iodine, okay, changes directly into a gas under suitable condition, okay, of temperature and pressure. Iodine moves from higher concentration to lower concentration. So this one is more like a bio. Okay, which row names this process? Okay, so solid change into gas. Okay, so the iodine gas moves from high concentration to low concentration. Which row names these two processes? Okay, so this one is going to be, first is going to be, I already mentioned just now, solid to gas is going to be sublimation, and moving from high concentration to low concentration is going to be what? Brownian motion or diffusion? Are you sure? No. Okay, what is Brownian motion? Brownian motion is random movement. Okay, when you have something, they move here, hit here, move here, move here, move here, move here, move here. This is called Brownian motion. Irregular, random motion. Yeah, Brownian motion. So this term Brownian motion was discovered by Brown. Okay, I do not know his full name. Okay, so Brown, he was observing the dust particle. Okay. On a microscope or much more a device, okay, and he noticed that the dust particle keep on moving randomly like what I showed just now. So he concluded there must be gases that is actually hitting the dust particles, and the dust particle is moving and hitting the wall of the container, and that's why he called this as Brownian motion. So that's why gas particles, we say gas particles, they move in a random and irregular manner. Okay, that's the reason. Okay, so diffusion, okay, high concentration to low concentration. Okay, slightly off topic, okay, which is going to be your bio. Okay, bio, low concentration to high concentration, that is going to be what? Active transport, yeah, or even osmosis also, right? No, yeah, no. I think osmosis also. No, yeah. Follow higher to lower. Yeah, of course it must go through permeable membrane, but osmosis, please check again, yeah, because for example, if you put a plant cell, okay. No need bio, yeah. So if generally you put a vegetable and you put it inside salt water, what will happen to the vegetable? It will become not soggy. It will not become soggy because the water from the vegetable goes out. Yeah, why it goes out? Because outside the concentration is higher. So from low concentration to higher concentration. Okay, so anyway, you check, yeah, you check on this. Okay, so number 7, okay, there are 3 isotopes of element hydrogen. Okay, so actually this is wrong, yeah, they say hydrogen, deuterium and tritium. This one is known as protium. Okay, protium. So anyways, it's okay, yeah, hydrogen, deuterium and tritium. And then which statement about this isotope of the same element is correct? Okay, they generally isotope, okay, they have the same number of proton. Okay, they have the same number of proton, different number of neutron. So if you look over there, okay, which one is correct? I think straight away is a giveaway. Yeah, they have different number of neutron. Okay, so different number of proton? No. They have the same mass number? No. Because if you have different number of neutron, the mass will be different. Yeah. And then they have different number of electron? No. Even ions, they have different number of electrons. Okay. So we ion and atom. So we cannot use that to differentiate that they are isotopes. Okay. So therefore, okay, the answer over here is going to be B. Number 8, which particle contain the most electrons? Okay, so if you want to find out which one contains the most electrons, so first, okay, you will be given a periodic table for this. Okay, so you need to check. Okay, this one is going to be 8. Okay, and this is going to be, helium is what? Helium is 4, 2. Oxygen 16, 8. Cl 35.5 and 17. Magnesium 24 and 12. All this you can get it from your periodic table. Yeah. Where do we find the periodic table? Yeah, at the end of the paper there is periodic table. Yeah. So please check, okay, your paper itself. Okay. So so many questions. Yeah, but here, okay, you can see all this information. Okay. So for example, helium just now. Okay, do remember, okay, even though helium here is written 2, 4, okay, we follow this one. Okay, what is the here? Okay, atomic number at the bottom is relative atomic mass. Okay, but when we write down, okay, like for example, helium here, they have written atomic number 4, atomic number 2, and then it will look like this. But when you write down, okay, when you write down in answers and so on, it should be written as helium 4, 2. You see the difference? Yeah, the one at the bottom, okay, bottom left must be the proton number. Okay, the one at the top must be the mass number. Okay, please remember this. Okay, don't get confused. So how do we differentiate? The bigger number generally, okay, is going to tell us the mass. Yeah, most of the time it's going to be like that, except for hydrogen. Hydrogen is 1, 1. Yeah, okay, but other than that, okay, if I ask you for platinum, what is the mass number for platinum? Yeah, automatically the bigger one, 195. If I want to know what is going to be the number of electron of cadmium, yeah, automatically you should know the electron is the same as proton. So automatically 48. Yeah, you need to know all this. Okay. Now I'll go back again. Which particle contains the most electrons? Okay. So proton supposed to be, so I'll just use this value. Yeah, so proton and electron. So helium is 2, 17, magnesium is 12. Okay, so you see proton 8, electron supposed to be the same as 8, but okay, you see 2 minus, extra 2 electrons. So from 8 plus 2, 10. Neutron, what is going to be neutron? The difference. Okay, 16 and 8, so difference is 8. Okay, I will skip the neutron part over here because they want electrons only. Yeah, so proton 2, electron 2 also. Proton 17, electron supposed to be 17, but because of negative, so it's going to be 18. Okay, and then for magnesium, proton is going to be 12. And then electron supposed to be 12, okay, but okay, because there is 2 plus, it means they have lost the 2 electrons, okay, therefore it will be 10 electrons. So they want the most electron. So the most electron over here, you see 10, 2, 18 and 10. So the most electron is going to be C, 18. Okay. Next, number 9. The table shows the number of neutrons and protons of some atoms of isotopes. Okay, and you can see all these proton and so on. Okay, how many atoms are those of non-metallic elements? Okay, non-metallic elements. How do we see from here? Okay, non-metallic elements. Okay, so generally, okay, if you look at, okay, the number of proton, Okay, if you look at proton, we can generally look at our periodic table and find out. Okay, if you have 8, okay, or you want the simple way, okay, we write it down. We assume proton is going to be, in this case we are taking it as the same, proton is the same as number of electron. Okay, so 8 is 2.6. Okay, electron is also 8, so 2.6. So if it is 6, this belongs to group number what? Guys, stop sleeping, focus. Yeah, group 6. Group 6, metal or non-metal? Non-metal. Group 1, group 2 and group 3, they are metal. Yeah, so group 6, non-metal. K is non-metal. Okay, now how about L? Okay, 2, 6 again. Okay, of course it's going to be non-metal also. You can ask me why we are not looking at the electron in the ion. We are looking at, okay, atom. Okay, we are not looking into ion. Okay, so we have to look at the proton. Proton will be the same as number of electron. Okay, so we will look into that. So this one, 2, 8, 7. So group 7. Group 7 is non-metal also. Okay, 17, 2, 8, 7, non-metal also. Okay. 19, 2, 8, 8, 1. Okay, group 1. Okay, and this one is 2, 8, 8.1, group 1 also. So both of them are metal. Okay, group 1 are metal. So how many are those from non-metallic elements? 4. Okay, hope this is clear. Okay, next. Number 10. The diagram shows the electronic structure of a particle with nuclear number. Okay, or nuclear number they already defined for you is mass, okay, of 40. Okay, so they are asking, okay, which statement about above electronic structure is correct. So let's write down first. First is 2 dot, then you have 8 electrons, then dot, there is another 8. Okay, total number of electron is going to be 18. Okay, 18. So they even mention, okay, the mass number is 40. Okay, mass number is 40. So do remember, number of proton and number of electron must be the same, because if it is element, yeah. So let's say proton is 18, electron is 18. Can you find the number of neutron? Neutron is what? What's the difference? Difference only, right? The nuclear number, mass number minus proton number. Okay, so the mass number is 40. Yeah, proton you already know is 18. So 40 minus 18 is going to be 22. So we can find out all these details before we even try to answer the question. The number of proton is 40. Wrong. The number of proton is 18. The number of electrons is 40. No, we just calculated just now. Electron is 18. It loses 2 electron. Okay, it loses 2 electron. How do I know it loses 2 electron? Okay, hold on, yeah. The diagram shows electronic structure of a particle with nuclear number 40. Which statement about electronic structure is correct? Okay, 40 electron is 18 to 8. Maybe this is not the actual what I mean. Maybe they this is not atom. Okay, this is not atom. So it loses 2 electron, possible. Okay, maybe it already lost 2 electrons. Okay, the number of neutron is 18. Not really. Number of neutron we calculated 22. The diagram shows, okay, nuclear number 40, proton 40, definitely wrong. Electron 40, definitely wrong. It loses 2 electrons. Actually, it doesn't lose 2 electrons. Okay, if you take it as a particle, the number of neutron is 18, 40, and then electron is 18, supposed to be 22. I think something is wrong with the question over here, yeah? So I will take it as, please change this into 22, yeah? So I will assume that this is atom, yeah? Maybe I do not know what is the point of view of the question. If they view this as ion, then it should be mentioned as ion, okay? But they didn't mention as ion, so I'm taking it as an atom. So if it is an atom, okay, if you take it as this entire thing as an atom, okay, they do not lose the electron, okay, but they say, yeah, particle. They didn't say isotope or anything, yeah. So I'll take it as D, yeah, taking into consideration that 18 must be changed into 22, or maybe the 40 must be changed into something else, yeah. Now 11. Helium and neon exist as monoatomic gases at room temperature and pressure. Okay, so statement number 1, helium and neon have 8 electrons in their outer shell. Now, generally most of the time it will be correct, but because it's helium, okay, helium, it has, okay, maximum of helium, if you look at the periodic table, is 2, 4. Maximum electron that it has is 2, yeah. So if you have the outermost electron 8, we call it as octet structure. But for helium, we always say duplet, okay, because 2 electrons. But generally helium and all the noble gases, okay, they are unreactive, okay, they are inert, because all the last shell of electrons, okay, they are complete. Okay, they are complete. So in this case, helium and neon have 8 electrons in the outer shell. No, okay, this is wrong. Okay, helium and neon are unreactive, correct. Okay, so statement 1 is correct, no. Statement 1 is correct, no. Statement 1 is incorrect. Statement 2 is correct. D will be the answer. Next question. Which option has a mixture of diatomic molecules of elements used in the formation of ammonia? So to form ammonia, okay, ammonia is NH3, okay, ammonia is formed from something that contains nitrogen and something that contains hydrogen atom, but they are formed from diatomic molecules, they already mentioned. So ammonia is formed from nitrogen N2, nitrogen gas. Okay. So let's continue with question 13. So which of the following diagrams containing elements? So if you look over here, what is element? Element is going to be a compound. Yeah, it can be atoms, okay, of the same element. Or it can be also molecules containing the same element. Yeah. So if you look over here, okay, you can see that, okay, this is going to be one element. Okay. So this is going to be another element. Okay. For example, it can be Cl, so Cl2, and then it can be also Br and Br. Okay. So they are, okay, elements, okay, and another elements, okay. So number 1 is correct. Okay, number 2, yes, definitely is going to be correct. Element is going to be atom of the same element, okay. And even this one, number 3, is also correct, okay. So although it's a molecule, but it contains the same elements, okay. So they are going to be considered to be elements. Okay, element and element. Yeah. So elements, and for 4 is incorrect. Okay, because different elements. Okay, different elements joined together. Okay, they are going to be compounds, so we don't call them as elements anymore. So it's going to be 1, 2, and 3. Okay, so what is element? Okay, element is atom or molecules. Okay, from one single element. Okay, from one single element or atom. Compound. Okay, compound is going to be, can be 2 or more elements chemically bonded. Okay, now next. Okay, 14. The diagram below shows the arrangement of atoms in 4 substances. Which substance will conduct electricity in both solid and molten state? Okay, in order to conduct electricity, you need free moving ions, okay, or free delocalized electrons. Okay, definitely this is going to be a structure of diamond. Okay, so we this is not going to conduct electricity. This is going to be, okay, if you go and read about it, yeah, so this one, okay, you can see different element and another different element. This is SiO2, yeah, but basically, okay, this is going to be a giant structure. They do not conduct electricity. Okay, and if you look over here, this is a structure of metal, okay, where you have the ion, and all these are delocalized electrons. Okay, so do remember, okay, delocalized electrons, okay, they can conduct electricity. So this will be the answer. Okay, but okay, hold on first. They have mentioned that in both solid and molten state. Yeah, so metals, okay, they can conduct electricity in solid form. In molten form also they can conduct electricity, yeah, because they are going to be delocalized electron. Okay, but here for D, this is like a ionic compound. Yeah, so ionic compound, okay, they have positive and negative charges of ion. So what happens over here, they cannot conduct electricity when they are solid. Why? Because there is no free moving ions. Okay, the ions are not they are bonded, they cannot move around. Okay, but when it comes to molten, yes, molten ionic compound, they can conduct electricity, but not in solid form. Okay, in molten part, okay, what happened? The ions will become free to move. Okay, they can actually move here and there, so they can conduct electricity. But ionic compound cannot conduct electricity when they are in solid form. Please remember that. So the answer is going to be C for this. Now 15. Which statement about solid sodium oxide and solid carbon dioxide is correct? Yeah? Sodium oxide, okay, Na2O, carbon dioxide. Okay, so you can see that. Okay, solid sodium oxide, okay, can conduct electricity. Yeah, please remember just now only I told you. Okay, sodium oxide is an ionic compound. Okay, so if they are solid, they cannot conduct electricity. Yeah, so statement A is wrong. Okay, solid carbon dioxide, generally carbon dioxide is a covalent compound. They are metal, non-metal and non-metal, so covalent compound. Covalent compound do not conduct electricity in any state. Yeah, so this is also wrong. Now solid carbon dioxide can conduct electricity, again no, yeah, wrong. And then solid carbon dioxide can conduct electricity, no, yeah. Now C, solid carbon dioxide is ionic, no. Okay, solid carbon dioxide, even non-solid carbon dioxide is always covalent. Yeah, solid sodium oxide is ionic, okay, while solid carbon dioxide is covalent. Yeah, so the answer is D. Okay. So D, 15 D, correct. Okay, now next. Which of the following statements correctly differentiates a compound and a mixture? Okay, a compound, okay, can be broken down into its element by physical means. No. Compound, okay, can only be broken down using chemical means. Yeah, cannot be physical means. Only mixture can be separated using physical means. Yeah. So statement A is wrong. Okay. The chemical properties of a compound are different from its constituent elements. Okay, correct? While the chemical properties of mixtures are the same as those of its components. This is correct. Yeah. So chemical properties, okay, are going to be different. Yeah. Let's say for example carbon. Okay, their chemical property will be different if you have carbon in form of carbon dioxide. Yeah. So they are different. Now, C. A chemical reaction takes place when a mixture is formed. No, yeah. Chemical reaction takes place only when a compound is formed. Yeah. So this is wrong. The component of a mixture are mixed in fixed proportion. No, yeah. Mixture is not a fixed proportion. Yeah. So mixture can be any proportion. Okay, but compounds is going to be in a fixed proportion. Yeah. Proportion means like this. If you have compound CO2, yeah, 1 mole of carbon atom and 2 moles of oxygen atom, carbon dioxide. Yeah, it's a compound. Yeah, but mixture is like water and tea. Yeah, water and tea. It's just a mixture. There is no proper proportion for it. Now 17. Which element has the same number of shells? Okay, as aluminium. So if aluminium, okay, let's look at aluminium. Aluminium is going to be, okay, wrong spelling. So aluminium 13. So 2, 8, 3. Okay, total 3 shells. Okay. So boron. If you look at your periodic table, okay, 5. This is 12. Calcium is 20. Gallium I don't remember. So gallium, let's look for gallium. Okay, gallium, Ga, yes, 70. Okay, 70. Sorry, 31. Okay, 31. So let's look at how to write the electronic configuration. So it's going to be 2, 3. Okay, so we follow 2.8, follow .8, and so on. So 2.8 and 2. So you get 12. So 2.8.8 you get 18. So you need another 2. So you have 20. 2.8.8 18. If you put another 8, okay, that's going to be 26. Okay, so you need another 5, okay, to make it 31. Okay, so now if you're looking for number of shells, okay, number of shells, easily it's going to be 3 shells. Okay, so if you look at here, 3 shell, yeah, this one, 2 shell, 4 shell. Okay, shell we look from here. Yeah, so B will be the answer. Next, 18. What is the chemical formula of the chloride of the element with the following electronic structure? Yeah, chloride Cl, okay, or Cl minus. Okay, Cl minus, or let's see, it's also in group 7. Okay, chloride is going to be group 7. So now, okay, if you look at this element, okay, what is the formula of this element? Okay, if you look over here, the electronic configuration is going to be 2 and then 4. Okay, 2, 4. So there are total 4 valence electron. Okay, there are 4 valence electron. Okay, but if you look over here, okay, if 2, 4, okay, total number of electron is 6, proton number is 6. If you look at your periodic table, okay, having proton number of 6, okay, is going to be carbon. Okay, must be carbon. Okay, lithium is only 3. Yep. So carbon. So carbon, okay, which is going to be group 4, it has to join with Cl. Okay, so 4 valence electron. So if you have Cl, okay, they are going to join with 4 Cl. Okay, so if you want to draw, okay, something like this, okay, and you can complete that. Okay, like this. Okay, and you repeat this entire thing. Yep. So basically, okay, it's going to be CCl4, not CCl2. Okay, that's the answer. Now 19. Which of the following substances is a good conductor of electricity? Okay, so good conductor of electricity, yeah, the best is of course if you have metals. Okay, but here carbon monoxide, graphite, methane, and diamond. Diamond do not conduct electricity. Methane, CH4, is a covalent compound, do not conduct electricity. Carbon monoxide, okay, is also going to be a covalent compound. They do not conduct electricity. Okay, graphite on the other hand, okay, although being covalent compound, or to be exact, giant covalent compound, okay, but okay, they have graphite have special property, okay, because each of the carbon, okay, is going to be bonded to 3 different carbon. Okay, 3 different carbon. So if they are bonded with 3 different carbon, okay, each of them have 4 electrons, 4 valence electrons. So each of them will have 1 electron each. So they are arranged, okay, in a hexagonal layer, and it will repeat and repeat and repeat. Okay, so each, if you look at it, okay, this giant structure, 1 layer and then another layer. Within the layer, okay, there is going to be so many electron, 1 electron to each of the carbon over there. So this electron, okay, they can actually move around, so they can conduct electricity. Okay, in simple form, okay, if you look at giant structures like diamond and graphite, the one that can conduct electricity is going to be graphite. Okay, so just remember that. Yeah. So the answer is going to be graphite. Now the information below gives the electronic structure of 4 atoms. Okay, and which of the following can combine to form, okay, an ionic compound? Ionic compound is going to be formed between metal and non-metal. So metals are going to be from group 1 to group 3. Okay, non-metal, these are going to be group 4 all the way to group 7. So if you look over here, how do we know the group? Yeah, so you just look over here, 1, 4, yeah, 4 valence electron, 7 valence electron, 8, yeah, totally out of the question because it's noble gas, yeah, inert, group 18. Okay, N will not be the answer. So even though you see N, yeah, automatically out. Yeah, so if you have K and L, so you see K and L, okay, metal and something, yeah, so definitely cannot. Yeah, it must be non-metal and non-metal, cannot. So any even K over here cannot. Yeah, cannot. So L and M, okay, L is going to be non-metal, M is also non-metal, group 7. So that will be our answer over here. Okay, now next, propane, also known as bottled gas, is a colorless hydrocarbon with the chemical formula of C3H8. Okay, which one is the equation represents the complete combustion of propane? Propane, C3. Yeah, so if you look at C3H8, okay, when you have oxygen, they will give you carbon dioxide and water. So you can eliminate some of it. Okay, complete combustion, this is wrong. Yeah, carbon monoxide, this is also wrong because carbon. Yeah, and then this is also wrong. Okay, hydrogen gas, okay, most likely will be this one. Okay, but check whether it's balanced or not. 3 carbon, 3 carbon. Hydrogen 8, 4 times 2, 8. Yeah, oxygen 10. Okay, 3 times 2, 6. 4 times 1, 4. Okay, 10. So the answer is going to be A. Okay. Now, question number 22. Diazine N2H2 is found in many natural products and frequently used as flavoring agent. What is the percentage by mass of nitrogen in N2H2? To find the percentage by mass, okay, nitrogen, okay, is going to be 14. Okay, if you look at your periodic table, yeah, the mass, okay, the relative atomic mass. So the percentage of mass is going to be, in this case, you have how many nitrogen? You have 2 atoms of nitrogen, 2 times 14 divided by mR, the entire thing. Yes, so 2 times 14 plus 2 times 1 and then times 100%. So that's going to be 28 plus 2 times 100%. So 28 over 30 times 100%. Okay, 28 times 30. Okay, so let's actually bring our calculator. over 30. Okay, that's going to be hold on, suddenly we have advertisement. Okay, how do we get this? Sorry. So yeah. So let's do it again. Yeah, 28 divided by 30, 0.93. Yeah. Okay, so 93%. Okay, so 93%. So 93%. Okay, the answer is C. So number 22, answer is C. Yeah, correct. Now, the chemical structure of kaolin clay, okay, was shown below. The formula is often written as the following. What are the values of X and Y? Yeah, so let's look at this. Okay, so how many aluminium that we have? Yeah, we have 2 aluminium, okay, Al2. How many oxygen? 1, 2, 3, 4, 5, 6, 7. 7 oxygen. Okay, but now they have SiO2. Yeah, so let's actually erase a bit. Hold on. So Al2, okay, SiO2. Okay, so maybe it is related to SiO2. Let's say, for example, SiO2. We take SiO2. Okay, so let's take this as Al2 O1, 2, 3, and then bracket SiO2. How many? 1 time, 2 times, 2 times. So if you take this, okay, aluminium, okay, will be 2, oxygen will be 3, okay, and then SiO2 2. Yeah, so X will be 2, Y will be 3. So that's going to be the answer, B. Now 24, zinc blend. Okay, zinc blend. Zinc S, yeah, is reacted with oxygen to give zinc oxide and releasing sulfur dioxide gas based on the following reaction. So what is the correct ratio of the coefficient of the reaction below? So basically you just need to balance the equation. So you have zinc, okay, you have zinc, okay, sulfur 1, okay, oxygen, okay, there is 3 oxygen over here, there's only 2 oxygen, so you just need to put 3 over 2. Okay, 2 and 2 will cancel, you get 3. Yeah. So this one, okay, you times everything by 2, so you have 2 zinc and then 3 O2 to give you 2 this and then 2 SO2. Okay, so the coefficients will be 2, 3, 2, 2. 2, 3, 2, 2. This will be the answer. Now next. Okay, so let's start, okay, with question number 26. Okay, you see here, okay, ionic compound of the element X and oxygen has the formula XO. Okay, the MR of XO is 79.5. So they are asking what is the MR of the chloride of X. Okay, so first of all, okay, we need to know, okay, this is an ionic compound X. Okay, O is 2 minus always. Yeah, so X will be 2 plus. Okay, that's why it's XO. Okay, first of all, you need to find out X is X2 plus. Okay, and then, okay, they say that the MR is 79.5. Okay, so it means now XO, okay, we know this is going to be 16, okay, from your periodic table. Okay, so X plus 16 equals to 79.5. You can find out the MR, okay, or AR of X, okay, which is going to be the AR of X is 79.5 minus 16. You calculate for me, tell me the answer, hurry up. 60? 62.5. Now, so they are asking what is the MR of the chloride. Okay, chlorine is non-metal, M2 plus is metal. Okay, therefore, okay, it is going to be ionic compound. 60? 3.5. Okay. So we know that, okay, M is M2 plus group 2, yeah, ion, and then chloride, okay, so it's going to be metal and non-metal, so it's ionic compound. So it's going to be X, okay, X2 plus, and then Cl, chloride, yeah, so Cl minus. So when I join them together, okay, I am going to actually have this one must times by 2, yeah, so I will have XCl2. You need to know that this is the compound, the ionic compound that will be formed. Okay, so once you have this, okay, they are asking the MR. Okay, so the MR X you have found out is 63.5, Cl2, so 2 times Cl is 35.5, so 35.5, that's going to be 63.5 plus 71, that's going to give you 134, yeah, 133.5, 71. So 134.5. Okay, so you just look at, okay, the option D is going to be the answer. Is that clear, everyone? Okay, so nobody have the question paper with you, and I'm not actually putting it into Zoom, so you must be looking over here, yeah. Okay, so please focus. Okay, now question number 27. Okay, if it is too small, yeah, just follow what I'm writing over here, yeah. So I will erase these parts. Okay, question number 27. So ammonium hydroxide, okay, on warming decomposes to form ammonia gas and water, and you can see the equations given over there. Now in an experiment, okay, they have warmed, okay, they have involved 2 moles of sample of ammonium hydroxide. So I'll just put it over here, 2 moles, yeah. And then they are asking what is the volume of ammonia evolved measured at room temperature and pressure. So in order to do this, first you need to find out what is the ratio according to stoichiometric equation. So we know that this is 1, so 1, every 1 mole will give you 1 mole and 1 mole. Yeah, So Terence, I hope you understand this. Yeah, follow the ratio first. Then after that, now if you have 2, okay, so we are looking for ammonia. Yeah, so every 1 to 1, 1 to 1. So of course, if you have 2 moles, then you are going to get 2 moles as well. Okay, so 2 moles of ammonia will be formed, and we know that 1 mole of any gas at room temperature and pressure will occupy 24 dm cube. Memorize, yeah? And then you know this is going to be 2 moles of ammonia. So 2 moles of ammonia times by 2, so it's going to be 48 dm cube. Okay, 48 dm cubes, so the answer is going to be C. Now, I just want to check, okay, if let's say they give the answer in cm cube, okay, so how do you convert 48 dm cube into cm cube? Divide by 1000 or times by 1000. Okay, so do remember this. Okay, 1 dm cube is 1000 cm cube. Okay, so you need to times. Okay, you need to times, dm cube is bigger, yeah, so you need to times by 1000. Okay, please remember this. Okay, now next. Question number 28. Now, 100 cm cube of sulfur dioxide is reacted with 100 cm cube of excess oxygen in equation shown below. Now, this reaction is very special. Why this reaction is very special? Because all of them, they are in gaseous form. Okay, so if they are all in gaseous form, you do not need to change them into number of moles. You can use the ratio using gas volume itself, okay, because 1 mole is 24, okay, it means the volume is directly proportional to the number of moles. So you do not need to go and say, okay, 100 cm cube, I need to change it to dm cube. Okay, I divide by 24, then find out how many moles. Then I go and calculate the other moles. Then I'm going to calculate, change back into volume, for example. No need to do all that. But the criteria is all of them, okay, all the reactant and product must be in gas before you use this assumption. Okay, in this case, all of them are in gaseous form. So if you have 100 sulfur dioxide, take it as like number of moles, yeah, 100. And then oxygen is going to be also 100. And they mention it's going to be excess oxygen. It means not all of them, okay, reacting. Okay, so let's actually see, okay, which one, they say they not all of them reacting. It means this 100 completely reacted. Okay, completely reacted. 2 moles to react with 1. Okay, completely reacted, so this is 100. So 2 to 1. Okay, so how many moles of or how many volume of oxygen reacted? 2 to 1. If 2 is 100, 1 is 50. It means out of this 100, only 50 reacted. Remaining 50 is the excess. Okay, is the excess. So which one do we use for calculation? The one, of course, the one that is limiting, the one that I circled. Okay, so you don't simply use the 100 and so on. Please actually identify which one is excess and so on. In this case, they are already very helpful. They already tell you which one is excess. But in future, maybe they are not going to tell you. You have to use the eeny, meeny, miny, mo method and identify and so on. I already told you, okay, how to identify limiting reagent. Yeah. So in this case, okay, this is going to be 50. So you want to find out what is going to be the volume of sulfur dioxide. Sulfur dioxide, 2 moles. So you just follow 2 to 2. Okay, 2 to 2 is going to be 100 over here. Okay, so the answer over here, the volume of SO3 produced should be 100. The volume of oxygen left, okay, you used up 50. Okay, 100 minus 50, 50. Yeah, the leftover is going to be 50. Okay, so that's going to be B. If they ask you, what is the leftover of SO2? Let's say volume of SO2 left, and then cm cube. What will be the answer? 0. Yeah, so it should be 0. Okay, because all used up. Okay, they can also play around that. Yeah, maybe they give you 3 rows. Yeah, 3 rows and ask you to fill up. Okay, anyways, okay, I will move on to the next question. So you can see so many calculation questions. Okay, so later at the end of the class, I will tell you what need to be prepared. Okay, so the next, okay, I can tell you now also, the next test, okay, is also going to be chemical calculation related. Okay, so that's going to be next Friday. Okay, please prepare. Okay, now, so total of, I think last time we had 2 tests on chemical calculation, so another 1 more. Okay, of course, do expect it will be more difficult. Yeah. Now, 25 cm cube of aqueous 0.1 mole per dm cube. So now you see it is already changing into concentration related question. What is the formula for concentrated related question? There is a formula. Yeah, some teachers will say concentration MV divided by 1000. Okay, basically the idea is the volume. If it is cm cube, you divide by 1000. Okay, but rather than trying to remember so many formulas, okay, we know the concentration is this in dm cube. So if you have 25 cm cube, change it into dm cube directly. 25 divided by 1000. So you will get 0.025 over here. Okay, Michelle, focus over here. Now you will get 0.025, okay, dm cube over here, and okay, we can find out how many moles, okay, of this. Okay, how do I get? Okay, we know the concentration equals to number of moles divided by volume. So if I want to find, so it's going to be 0.1 number of moles, volume is 0.025. Number of moles is 0.1 times 0.025. You will get 0.0025 moles. Okay, this is for sulfuric acid. Okay, so I will write down over here 0.0025 moles. Okay, now next they say that it neutralizes exactly 20 cm cube. So 20 cm cube, let's change it into dm cube. Okay, so divide by 1000, 0.02 dm cube. Okay, so what is the mole of sulfuric acid, okay, required to neutralize 20 cm cube of magnesium hydroxide solution? This is very easy. Okay, I thought it's going to be difficult. Okay, they already said they are going to be using something to neutralize this. Okay, let me check first. Yeah, so this one, sulfuric acid, exactly neutralizes 20 cm cube of aqueous sodium hydroxide, magnesium hydroxide. Yeah, I think there is no catch over here. So the answer is already, okay, we have already calculated 0.0025. Okay, so that's going to be our answer. Okay, they are going to neutralize 20 completely. Yeah, so it means that you just need to find the number of moles of the sulfuric acid. That's it. Okay. Okay. Now, question number 13. Okay, a sample of nitrogen gas, okay, contains the same number of atoms, okay, as found in 0.50 mole of oxygen gas. Okay, so let's actually look at the number of atoms in 0.5 moles of oxygen. 0.5 mole, every 1 mole has, okay, the Avogadro constant, yeah, 6 times 10 to the power of 23, yeah, so particles. So in this case, if you have 0.5 moles, okay, oxygen, 0.5 times 6 times 10 to the power of 23, okay, molecules. Why? Because it's O2. But they are asking atom, okay. So how many atoms are there in 1 molecule of oxygen? O bonded with O. So how many? 2 atoms. Yeah. So you need to times by 2. This is something that we have done in the very beginning. Yeah. So 1 mole, okay, has 6 times 10 to the power of 23 particles, Avogadro constant. Okay. If you have, okay, O2, it means you have, let's say, 0.5 moles. You have 0.5 moles times the Avogadro constant, then molecules, okay, of oxygen. But if they are asking atom, okay, 1 molecule of oxygen has 2 atoms of oxygen. So you need to times by 2. So that's going to, this value, okay, 0.5 times 2 is 1. Okay, you will get 6 times 10 to the power 23 atoms of oxygen. Okay, so I want to find out, okay, what is the mass, okay, of the sample of nitrogen gas having the same number of atoms as this. Okay, so it means that they are telling nitrogen supposed to be N2. Okay, nitrogen supposed to be N2. So they are asking what, okay, contains 6 times 10 to the power of 23 atoms of nitrogen. Okay, so if you are looking into, let's say, 1 mole of nitrogen, okay, 1 mole of nitrogen, it contains 6 times 10 to the power of 23 molecules of nitrogen. So if you are calculating for atoms, okay, so it's going to be 1 molecule of nitrogen has 2 atoms of nitrogen. So 2 times 6 times 10 to the power of 23 atoms of nitrogen. Okay, now how do I relate to this? Okay, of course I need to divide by 2, right? 2 times Avogadro constant. Okay, so this 2 times Avogadro constant is for 1 mole of nitrogen. If you want to get Avogadro constant only, okay, it must be divided by 2. How we can divide by 2 is by changing this 1 mole to become half mole, 0.5 mole, because 0.5 mole, okay, will be 1 mole is this much, 0.5 mole is half of it. So you divide this by 2, that's going to be, okay, that's going to give us 6 times 10 to the power 23 atoms of nitrogen. Anyone don't understand this? Okay, supposed to be, okay, if you have 1 mole, then you're supposed to get this, okay, but I want only this. Okay, if I want only that, so I need to divide these 2. Okay, how do I get to divide that 2? Okay, because this is for 1 mole, you get for 0.5 moles. Yeah, so you will get this same number of atoms. Okay, once you get that, okay, we know we are dealing with 0.5 mole of N2. Okay, not N, yeah. We are dealing with 0.5 moles of N2. They are asking the mass of the sample. So how to find the mass of this sample? Number of moles equals to mass over MR. 0.5 mass MR. This is 14 if you look at your periodic table. So 14 plus 14. So the mass is going to be 28. 14 plus 14 is 28. Times, okay, you times this 0.5, it's going to be, you will get 14 gram. Okay, so this is going to be, the answer is going to be 14. Okay, for those who are still confused, I will repeat again. Okay, you see here, oxygen, okay, generally 1 mole of oxygen, okay, they are going to have 6 times 10 to the power of 23 molecules. Okay, molecules. So if you are dealing with atoms, okay, you need to times by 2. Okay, you times by 2. But why there is 0.5 in front? Because they have been using 0.5 mole. They have mentioned in the question. So if you calculate this, you will get this number of atoms. So they're asking you to calculate the mass of nitrogen that has the same number of atoms as this. Okay, so I started off with nitrogen and I used the same formula. 1 mole contains this amount of molecules of N2. And then I try to convert to atoms. Okay, so still 1 mole. Okay, 2 times 6 times 10 to the power of 23. Why times 2? Okay, because N2. Okay, so I will get this value. But I want only this 6 times 10 to the power of 23. Don't want the 2. How do I change it to that? Similar to that. So 1 mole, I don't want 1 mole then. Okay, I only want half of the mole. Okay, so only when I have half of the mole, I can divide by 2. Okay, once I divide that by 2, Michelle Sandra. Okay, so once I divide that by 2, okay, thank you, Miss. So once I divide that by 2, I will get basically 0.5 moles. Okay, I will get 0.5 moles. Now I know 0.5 moles is the one that they are talking about, the nitrogen. Yeah. So again, we are still talking about nitrogen gas. Okay, that nitrogen gas contains atom. Yeah. So don't go and say, oh, I calculated for nitrogen 0.5 mole of N only. No. These are the common mistakes the students will make. Okay, 0.5 moles of N2. Yeah. So because we are still dealing with N2. And then number of moles equals to M over MR. Okay, then you have 0.5 equals to M divided by 28. Then you get 14 grams. Okay, if you have any questions, let's settle it now itself. Yeah, don't actually, sir, I'm still confused. Yeah, even you watch the video, it's not going to be helpful. Yeah, if you don't understand. Yeah, so this is going to be 14 grams. All okay, Henrietta? Okay, now let's go for question 31, which does not involve calculation anymore. Now, HCl is a strong acid. So which one of the following is not true for HCl? Yeah, before we go into that, the concept of strong acid and weak acid. Strong acid is not, okay, something that has pH close to 1, close to 2. No. Strong acid is an acid that dissociates or ionizes completely in water. Okay, they ionize completely. If you have HCl, completely they will give you H plus and Cl minus. If you have 0.1 mole over here, they will give you 0.1 and 0.1 complete. But if you have CH3COOH, it's a weak acid. They do not, okay, they do not ionize completely. They will partially ionize. So if you have 0.1 over here, the value over here might not be 0.1. Okay, it will be way less than 0.1. Okay, so although you can say 1 mole, 1 mole, 1 mole, no, it doesn't follow that. Okay, they do not dissociate completely. Sorry. Now, it produces hydrogen molecules when dissolved in water. Is that true? Acid produces hydrogen molecule. Hydrogen ion. Okay, they produce hydrogen ion. Not true. It liberates hydrogen gas when reacting with magnesium. Okay, this one we have learned. Okay, acid with metal will give you salt and hydrogen gas. And the hydrogen gas can turn, okay, or can actually extinguish the lighted wooden spleen, okay, with a pop sound. Yeah, so please remember that. Now, it liberates carbon dioxide when reacted with sodium carbonate. Yes, acid with carbonates, they will give you salt, water, and carbon dioxide. Okay, so that is also true. It dissociates completely. Yes, they dissociate completely. Strong acid. Okay, so the answer is going to be A. Not true. Okay, not true. This time they are like a very kind. They bold the not true. Yeah, but in the IGCSE and A levels, they do not bold the not true. Yeah, so Even with the recent papers, when we set the papers of BBS now, we are trying to follow the syllabus. Okay, so now we stop bolding that part. Okay, so it means if you make mistake, yeah, you make mistake. Okay, because Cambridge also they don't bold that part. So it's your responsibility to read the questions properly. Yeah, please remember that. Now, which pair of gases are both acidic? I think we discussed about this yesterday. Yeah, which one is acidic? Okay, so sulfur dioxide is pungent and is acidic. Yeah, so this one is acidic. Ammonia, pungent but basic. Okay, ammonia is basic, so no. Carbon dioxide, acidic. Okay, how do we test carbon dioxide? Lime water will turn into cloudy. Yeah, so ammonia, is it acidic? That's why I said no. Yeah, basic. Yeah, so this one no. Okay, carbon monoxide, what is the gas? Is it acidic? Is it basic? Yesterday only I mentioned this. Neutral. Okay, there are two gases in your textbook that they mention neutral. Okay, methane, CH4, and also carbon monoxide, neutral. Yeah, neutral gas. So no. Sulfur dioxide, acidic. Yes. Okay. Nitrogen dioxide, acidic. Okay. How do I know nitrogen dioxide is acidic? Okay, because acid rain. Okay, or if you can see it's non-metal. Yes, good. Okay, it's non-metal. Non-metal oxides. Okay, they are going to be acidic. Okay, so nitrogen dioxide, carbon dioxide, they are both acidic. Okay, but what is important over here, nitrogen dioxide, okay, is one of the gas, okay, is one of the pollutants. Okay, these pollutants are released from the factories and so on. If you have a lot of nitrogen dioxide or nitrogen oxides in your air, okay, that will give rise to acid rain. Yeah, how? Okay, it will combine with water, okay, with NO2, they will give you HNO3. Okay, so acid rain can be formed. Okay, similar with sulfur dioxides, okay, sulfur oxides that is actually released by the factory and so on. Okay, they will also contribute to acid rain. Yeah, so that those are the acid rain. Is carbon dioxide good? If it is in a natural cycle, okay, in a natural cycle, we breathe out carbon dioxide. It's good. Yeah, then plants take the carbon dioxide. Everything is good. But now there are we are disrupting the natural cycle. Because when we use vehicles, okay, those consumption of petrol, okay, the combustion produces carbon dioxide. Not only like carbon monoxide, all this contributes pollution. Carbon dioxide is actually pollutant as well. Okay, why? This is going to disrupt the natural cycle. Okay, we call it carbon cycle. But what happens over here is this carbon dioxide is one of the contributing factor of something. Okay, that is very very important. Yeah. So what is the condition or what is the situation that carbon dioxide is responsible of? Yeah, global warming. Yeah, you feel now, even I feel it's hot, okay, certain times, okay, it's because of the carbon dioxide. Okay, carbon dioxide is the main contributing gas, okay, for global warming. Okay, global warming, why we have global warming? Okay, the heat from the sun, okay, they come into our atmosphere. Okay, but this carbon dioxide, it prevents the heat from going outside again. So it will become like reflected again and again. So when it's reflected again and again, the heat, okay, the temperature of the earth will rise. Okay, will it be, what is the problem with that? Okay, this will contribute to a lot of other factors. Okay, the icebergs will start to melt. That will increase the sea level. Okay, the sea level is increased, because of high tide and low tide, because of the movement of the moon, okay, so it can cause, okay, it can cause certain areas of the world, okay, to be covered by water. Yeah, so slowly, that's why they say the land, okay, even last time, okay, if you see there's a lot of land and most of the continents are connected, but now most of the continents are separated, not because they get detached and move away, it's because those parts were covered by water. That's why we can have like for example, in Indonesia we can have durian, okay, and then Philippines also can have durian, but we don't have durians in US, okay, because they don't share the same continent last time, okay, so something like that, okay. So there are certain animals, they live within the same continent, like I forgot the name, yeah. There is one particular animal that is actually like being endangered, okay, it's like a half giraffe and half zebra, okay, so it's still there, okay, it's still there, okay, but it is only found in the African continent, okay, so it doesn't actually you cannot find it anywhere else, okay, because of this as well, because they cannot spread, okay, they just stay there, yeah. So anyways, come back over here, okay, number 33, which reaction below does not involve neutralization? So what is neutralization, Jesse? Salt, okay. Neutralization is acid plus base to give you salt and water, okay, salt and water. So in this case, okay, let's see, there is going to be water, 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 okay. So you can see there is no water in equation number 1, but just double check, this is acid, this is base, okay, this is acid, this is base, this is acid, this is base, so this is going to be the reaction that do not, okay, involve neutralization. So it means the exact definition is, even though we don't focus on salt, it means as long as they give you water, okay, it is going to be a neutralization reaction, okay. So acid plus base, okay, to give you water, okay, or any acid reaction that gives you water is going to be neutralization reaction. Now 34, potassium hydroxide is alkali. Now what is the difference between base and alkali? What is base, what is alkali? We always remember alkali is OH minus. Actually alkali is a base that is soluble in water. So there are few bases that are soluble in water, all the hydroxides, okay, not all of the hydroxides, so maybe group 1 hydroxide, sodium hydroxide, potassium hydroxide, group 1 salts are all soluble, okay. So hydroxides generally they are soluble, okay, so that's why it's alkali, okay. But base, what is a base? Okay, you can define base in many ways, okay, and even this question came out in IGCSE paper yesterday, okay. What is a base? Okay, the answer is, you can answer base is a proton acceptor, you can answer that, okay, base is a proton acceptor, or you can say base is anything that reacts with acid to give you salt and water. There are two definitions, yeah. So what is a base? Base is anything that reacts with acid to give you salt and water, or you can say base is a proton acceptor, okay, proton acceptor. So I'll write down over here, yeah, proton acceptor, okay, and then base is going to be anything that react with acid to give you salt and water. So this one came out only yesterday, and even SEC4 students, they are confused what to answer, okay. So it's only 1 mark question, and they do ask simple questions like this in IGCSE. Yeah. So yesterday was paper 4, if I'm not mistaken. Paper 4. Paper 4 is like a structured paper, structured question. Now, so how does the pH of potassium hydroxide change when excess aqueous hydrochloric acid is added? Now you see, potassium hydroxide is an alkali, so the pH should be more than 7. Let's say we take the pH of potassium hydroxide was 14 in the beginning. When you add the acid, what will happen? The pH will become less, because why? They are going to become slowly neutral, and then when you completely react with potassium hydroxide, there's only acid. So the acid is going to follow the acid pH. So the pH will decrease. Okay. So the answer must be pH must be decreased. Definitely cannot be this. Yeah. Now the other thing is it going to decrease from 14 and become constant at 7, or is it going to be decreased from 14 and they go to 1? Which one will be the answer? Alvina, you are adding ACl with potassium hydroxide. Potassium hydroxide is already 14. Yeah, you keep on adding. Okay, we know that, of course, potassium hydroxide 14, you add acid. Okay, of course, the pH will become maybe roughly decrease. Everyone knows it, the pH will decrease up to 7, for example. Then will it actually stay at 7 or continue to decrease? Stay at 7. That's common misconception. Yeah, it will continue to decrease because they say that excess of hydrochloric acid is being added. What's the meaning of excess? Excess means there's a lot. Okay, it means that potassium hydroxide is finished. When the potassium hydroxide is finished, from 7 it will go to become acid, because why? Now there is no potassium hydroxide, there's only acid. So they will measure the pH of the acid. So it will go to 1. Is that clear, Alvina? So this one will go to about 1. Okay, please remember this. 35. The table shows the properties of 4 compounds. Which compound could be ethanoic acid? So do remember, ethanoic acid is a weak acid. So the dissociation is partial. So dissociation of ethanoic in acid in water, is it high or low? Jake? High or low? It's a weak acid, partially dissociated. Partially dissociated, it means low. Low dissociation. So it should be low. And hydrogen gas is produced or not? It's still acid. It's still acid. Whether it's weak acid or strong acid, hydrogen gas will be produced if you are reacting with metal. So acid and metal will give you hydrogen gas. So the answer is yes. Now, Gianna, which is the use of sulfuric acid? As a bleach, as fertilizer, manufacture of ammonia, manufacture of sulfur trioxide. This might be, you might think that is a difficult question, but this is the part that I have assigned the project for each of you. So different people did different project. You see manufacturing of fertilizers, it requires sulfuric acid. It requires sulfuric acid, but let's say you don't know. Let's focus on the manufacturing of ammonia. To manufacture ammonia, the process is called Haber process, and it uses nitrogen and hydrogen gas. Nitrogen and hydrogen gas, and they are going to use the catalyst, iron catalyst. Okay, this one, please write down somewhere, yeah? So ion catalyst. So this one is going to be the for Haber process. And you cannot see at any point of time, there's no sulfuric acid is being involved over there. Okay, so no. Okay, now in the manufacture of sulfur trioxide, why you need acid? Sulfur trioxide, you just take sulfur and you react with oxygen, you get sulfur dioxide. Okay, you get sulfur dioxide, and after that the sulfur dioxide can react with oxygen to give you sulfur trioxide. Okay, but without the use of the acid. Okay, but they do use a catalyst for this. The catalyst used for this is V2O5. There is one group which has done this, so it's called vanadium 5 oxide. Okay, vanadium 5 oxide. So this one is the one that I told you to go and find out. Contact process. Contact process is a process to produce sulfuric acid. Okay, so this is only first two reactions. Okay, if you do not know, I write down everything for you. Yeah, as okay, this one is extra, but you can see even extra they are asking about it. Sulfur dioxide, okay, and then sulfur dioxide plus oxygen to give you 2SO3. You can use V2O5 catalyst. Then if you have SO3, they react with H2SO4 to give you H2S2O7. This is called oleum. And then H2S2O7 react with water to give you 2H2SO4. These are what we call as contact process. Okay, there are 4 equations, okay, under contact process. What is contact process then? Contact process is production of sulfuric acid. What is Haber process? Haber process is production of ammonia gas. Okay. Now, therefore, we know for sure, not this, not this. Bleach. Okay, we use Cl2. Okay, chlorine gas. Okay, so manufacture of fertilizers. Okay, so whether it's going to be manufacture of fertilizer or bleach. Okay, if you look at the answer, hold on. Where did I save the answer? So this is going to be question 36. So 36, the answer is B, yeah, in the manufacture of fertilizer. Yeah. Okay, so okay. Now can you see it's actually manufacture of fertilizers, yeah? So the answer is manufacture of fertilizers. Bleach, we use chlorine gas. Okay, so that's going to be the answer. Now, which substance, okay, is used as catalyst in the you see here, whatever that I have explained, they are asking again, which one is catalyst for the manufacture of sulfuric acid by the contact process? The catalyst comes in under the second reaction, which is going to be vanadium 5 oxide. Okay, so you see vanadium 5 oxide is the answer. Iron, okay, is for Haber process. Okay, lead, nitrate, nickel, normally no, but nickel there is actually a reaction, okay, but not in your syllabus. Okay, so please remember that. Okay, so okay, Gianna, so I forgot your name. Someone is absent. Cheryl is absent. Your name? Jocelyn. Okay, Jocelyn. Haber process is for what? To produce ammonia. Contact process for what? To produce sulfuric acid. What is the catalyst? Haber process. Iron. What is the catalyst for contact process? Vanadium 5 oxide. Okay, I want you guys to get this correct, yeah? So you see, I'll just put it over here. Haber. Okay, Haber process is production of ammonia. Contact process, okay, now me wake up. Okay, contact process, so that's going to be production of sulfuric acid. Okay, what is going to be the catalyst? Catalyst is going to be iron for Haber process. What is the catalyst for contact process? Vanadium 5 oxide. Vanadium 5 oxide. And what is the use? I think all this enough already. I think you just know this first. Okay, there are 4 reactions under contact process. If you want, you can refer to the previous notes just now. Okay, so Haber process, how do you get it? You get it from reaction of hydrogen and nitrogen to give you ammonia. Okay, next. Now, which statement about calcium carbonate, okay, is correct? So, I want Dave to answer this. Okay, calcium carbonate. Now, it can decompose to produce carbon dioxide on heating, correct? Yes. Okay, if you have calcium carbonate, decompose means they will break down, okay, with the heat. They will give you calcium oxide plus carbon dioxide, okay? So, calcium oxide plus carbon dioxide. Okay, but nitrites also can break. Okay, nitrites also can break. So let's say calcium nitrate. Calcium nitrate. Okay, calcium nitrate can break into calcium oxide plus nitrogen dioxide gas and oxygen gas. There are 2 types of gas for nitrate molecules. Okay. For nitrate compounds, okay, there are 2 types of gas that will be released. Nitrogen dioxide and oxygen gas, okay. So if you want to balance, of course, you can put 2 over there and then 6, so this one will be half, okay. Then you can times everything by 2, okay. So please remember that, okay. Anyway, this is correct, okay. It is used to neutralize alkaline soil, okay. It's supposed to be calcium carbonate is used to neutralize acidic soil, yeah. So this is wrong. It reacts with hydrochloric acid to produce hydrogen gas, okay. It's supposed to be acid and carbonate gives you salt, water and carbon dioxide. So this is also wrong. It turns universal indicator solution to red, wrong also, okay, because this is not acidic. Okay, so the answer is going to be A. Okay, let's move on. So you see here, the kinetic theory explains the properties of matter in terms of arrangement and movement of particles. Okay, so chlorine is a gas at room temperature. Chlorine molecules Cl2, which are spread far apart, move in random manner at high speed. Okay, and we are going to draw a dot and cross diagram showing the arrangement of valence electron in chlorine molecule. So chlorine molecule is a covalent compound. How do I know it's a covalent compound? Because chlorine is from group 7. Okay, so they must be sharing their electrons. So how do we start? Okay, so you can actually start by drawing 2 circles over here. Okay, so if I draw 2 circles, okay, I will just make them, okay, to overlap, okay, and then you can actually either just if you want, you can put another circle to show it's a chlorine, yeah. So in this case, if you don't want also, doesn't matter. So I just put Cl and Cl over here. Okay, so each chlorine, okay, must have 7 electrons in order 7 valence electrons, and in order to be complete, yeah, to be happy, they need 8 valence electrons, so 7 they need to gain one more electron. So if they need one more electron, they have to put aside one electron to be shared. Okay, so if you want one, you need to also let go of one or willing to share one more. Yeah, so one will go here. Okay, so you have the remaining 6 valence electron outside. So I will put cross over there, or you can put dot over there. Okay, and then okay, the next is going to be the other one. Okay, so this chlorine also must be willing to share. Okay, so dot. Okay, and then you will have 6 more electrons over here. So now if we just look at it, okay, each of these chlorine atom, okay, they are already going to have 8, and the other chlorine atom have 8 electrons. Okay, so this is going to be how you draw the dot and cross diagram, okay, for chlorine molecule. Now, how does the movement of the and the arrangement of the molecules in a crystal of chlorine differ from those in gaseous chlorine? So we want to compare, okay, the crystal chlorine, it means Cl2, okay, in terms of like say in solid, okay, in terms of solid, and then we want to compare gas. So basically we are comparing solid and gas. Okay, so movement, okay, how can you talk about the movement? Okay, can the gas molecules, the molecules of chlorine in crystal, are they free to move or not? Shouldn't be free to move. Okay, they will be, they are not able to move freely. Okay, that is movement. Arrangement wise, they are going to be arranged in a regular arrangement. Okay, regular arrangement. Okay, with little gap, okay, between the molecules. Okay, and if you compare with gases, okay, gases are going to be arranged, okay, movement wise, they are going to be rapid movement. Okay, or you can say movement in terms of vibrating. Okay, solid will be vibrating. Okay, but gases will be able to move from one place to another place, so rapid movement from one location to another location. Okay, and in terms of arrangement, okay, random arrangement, okay, with many gaps in between. Okay, so that's going to be the answer. So let's say, for example, I'll just write down here, crystal, okay, crystal chlorine, okay, will crystal chlorine molecules, okay, molecules will vibrate in a fixed position and arranged in regular manner with little or no gaps with other Cl2 molecules. Okay, so this is going to be for crystal. Okay, so gaseous chlorine molecule, okay, will move rapidly from one place to another okay, in random manner. Okay, remember last time I told you the movement rapidly and random manner. There is actually there is a term, okay, that is that we use. Okay, what movement starts with capital B? Brownian movement. Okay, Brownian movement. Okay, so from one place to another in random manner. So that's movement, arrangement. Okay, and arranged in irregular manner with many gaps between Cl2 molecules. Okay, of course, this is a full version. Of course, you can actually simplify whenever you write. Okay, but I write the full version. Okay, so I can share to you this document. You can actually read through. Now, use the idea of kinetic theory, okay, to explain the following. A sealed container contains chlorine gas. The pressure of the gas is due to the molecules of the gas hitting the walls of the container. Explain why the pressure inside the container increases when temperature is increased. Okay, so can you explain, maybe Michelle, can you tell me why pressure increase when temperature is increased? Okay, correct. Okay, so basically, okay, when temperature is increasing, temperature will provide the heat energy. Okay, this heat energy is going to be converted into kinetic energy. So that will make, okay, the molecules to move faster. So they will hit the container more. Okay, so there should be 2 marks. So you need to say when temperature is increased, okay, the temperature increases, the heat energy increases, which increases the kinetic energy of Cl2 molecules, and they will hit the wall of containers more and increase the pressure. Okay, now the apparatus below can be used to measure the rate of diffusion of gas. Okay, and if you can see over here, you have nitrogen, okay, N2Cl2, and okay, there's 2, okay, chlorine and chlorine. Yeah, something is wrong then. Okay, so the apparatus can be used to measure the rate of diffusion of gas. Experiment was done with the following gas results. Okay, so now we want to actually check. Okay, later we will come back to this. Maybe they are talking about chlorine in what state and so on. Okay, we'll come back to this.
But it's different temperature.
Oh, different temperature. Okay, good. So chlorine and chlorine at different temperature. Okay, so different temperature. So now, first of all, okay, rather than just focusing, there are 2 things over here. One is temperature. Another one, okay, I want you to look at, okay, the Cl2 and N2. I want to see which one is heavier. Okay, so N2, okay, if you look at N2, nitrogen is 14, okay, in your periodic table. 14 plus 14 is 28. Okay, that is the relative molecular mass. And if you look at the relative molecular mass for chlorine Cl2, okay, 35.5 plus 35.5, that's going to be 71. So it means that in this case, which one is more heavier? Okay, the one that is more heavier is chlorine. Okay, please remember, okay, molecules that are heavier will be difficult to diffuse. Okay, molecules that are lighter, they are going to be easily to diffuse. Okay, please remember that. So now let's try, okay, to answer the question. Under the same temperature and pressure, explain why chlorine diffuses slower than nitrogen. Okay, this is related to relative molecular mass. Okay, so I'll just write down the relative molecular mass of nitrogen is, okay, 28, and the relative molecular mass of Cl2 is going to be 71. Cl2 is more heavier, okay, than N2. Therefore, okay, heavier molecule will diffuse slowly compared to lighter ones. Okay, Cl2 diffuses slower than N2 at same temperature and pressure. Dave, everything all right? Okay. Where's Dave? Which one is Dave? Okay, Dave. Okay. Now, so Jake, okay? Okay. Now, compare the reason, okay, the diffusion of chlorine gas at 65 degrees. So now they are comparing, okay, chlorine at, okay, different temperature, yeah. So the chlorine was in 30 degrees, and then now we are comparing with chlorine at 65 degrees Celsius. Of course, okay, when you have, okay, at higher temperature, okay, as you know, more heat energy, okay, heat energy will be converted into kinetic energy. So therefore, chlorine molecules, okay, at higher temperature, they are able to move faster. Okay, therefore diffusion will be greater as well. So they can go through the all the places faster. Okay, so compare the reason with the diffusion. Yeah, so it means that at higher temperature, okay, at higher temperature, chlorine, okay, will diffuse faster because more heat energy will make the kinetic energy of Cl2 greater, making them able to move faster and diffuse easily. So everything you have learned, you just need to put it in words and use the proper terms to answer. Now, two isotopes are shown. Okay, so now I know, I want to know what are isotopes? Okay, what are isotopes? So Cheryl, can you tell me what are isotopes? Same proton number, different neutron number. Okay, same proton number, different neutron number. You can see this is the proton number, same proton number. Neutron, you see the difference of this, okay, 17 and 35, so 8. The difference over here is going to be 10, okay. So that is going to be, okay, the important thing over here, same proton number, different, okay, neutron number. Or you can say same number of proton but different mass. That is going to be another way to put it as well. Now, write the electronic configuration of chlorine. So in order to write electronic configuration of chlorine, okay, Max, should I take the smaller number or the bigger number? Electronic configuration. Smaller, okay, because we take the number of proton. Number of proton is the same as number of electrons. So 17. How do I get it 17 into electronic configuration? The first shell, maximum 2 electrons. Okay, so you put 2 electrons. Second shell, maximum how many electrons? 8. Okay, then the last one, in this case 70, so the last one supposed to be 7. 2.8.7. Okay, so 17. Now give one similarity in the atomic structure of these two isotopes. Okay, what is the one similarity in the atomic structure? Okay, there are many similarity over here. Okay, you can say that, okay, they have the same number of electron. Okay, they have the same number of proton. They have the same number of shells. Okay, but I think the one that you need to actually mention is the same number of proton. Okay, if you mention same number of electrons, still okay. Okay, so the best one is, okay, in terms of atomic structure, okay, they want structure, so same number of proton. Give one difference in the atomic structure of these two isotopes. Just now only we saw, okay, the difference is going to be neutron, okay, one is having 8 neutron, another one is having 10 neutron, okay, so therefore, okay, we are going to have, yeah, okay, oh, 18, sorry, so 18, okay, so this one is 20, okay, so 18 and 20, okay, so here, okay, give one difference in the atomic structure. The difference is going to be number of, in this case, even if you remove this one, number of proton is enough already. So here is going to be number of neutron. Now, chlorine forms a compound with phosphorus, okay. Now, chlorine is non-metal, I told you, group 7, okay. Phosphorus, okay. Phosphorus, okay, is it going to be metal or non-metal? Non-metal, okay, because group 5, if you look at your periodic table, group 5. So, phosphorus, non-metal, chlorine, non-metal, non-metal and non-metal, they are going to actually form covalent or ionic? Covalent or ionic? Ionic. Non-metal and non-metal, they have to share the electrons, so they are covalent. Ionic is going to be metal and non-metal. Yeah. So in this case, this is covalent compound. Okay, but anyway, they didn't test on that. They say that the compound contains phosphorus by mass, chlorine by mass. Calculate the empirical formula. So if you want to calculate this, okay, so we are going to actually put like this, Cl, then I put a table phosphorus over here, okay, then, okay, just put the percentage, okay, whether it's mass or whether it's going to be percentage, we take it the same, okay, so in this case, chlorine is going to be 85.13, phosphorus is 14.97, if you add these two, you should get 100%. Okay, what is the first thing that you need to do? You need to divide with the relative atomic number. Okay, Cl 35.5. Phosphorus. Okay, what is phosphorus? Okay, you refer to the periodic table. I think it's 31. Okay, but you just to be sure. Okay, phosphorus is 31. Okay. So you help me to calculate now. Give me in 3 decimal places. Okay, what we will get. Okay, so divide by 31. Okay, 85.13 divide by 35.5. 2.398 and then 14.97 divide by 31. 0.483. So I am going to divide with the smallest number. Okay, so divide by 0.483, divide by 0.483. I will get 1 here. So 2.398 divide by 0.483, and I will get 4.964. I will write down 4.964. And then now you simplify, okay, which is going to be nearer to 5. This is 1. So the empirical formula is going to be, okay, it's going to be for Cl, okay, Cl is 5, okay, phosphorus is going to be 1. So if you write down, okay, Cl5P also can, but normally, okay, we will write PCl5, okay, but if you write Cl5P, it's okay, doesn't matter, yeah. So this one I will write down, the empirical formula is PCl5, okay. The ratio is going to be for phosphorus and Cl 1 to 5, okay, 1 to 5. Now a sample of chlorine gas has a volume of 21 dm cube at room temperature and pressure, okay, and we want to calculate the mass of the chlorine. So every single time when you have gas, we need to know that, okay, a gas, okay, 1 mole of any gas, okay, of any gas will occupy 24 dm cube, okay, at room temperature and pressure. Must remember 24 dm cube. So now you have 21 dm cube. So up to you, okay. I will normally calculate like this. 1 dm cube is 1 mole, okay, 1 mole divided by 24. So every 1 dm cube is 1 over 24 moles. I want for 21 dm cube. 21 dm cube means I'm going to times this by 21. So this one also must times by 21. So how many moles? That's going to be 21 over 24 moles of Cl2, okay. So that is the number of moles, okay. So now, okay, do remember chlorine gas, yeah, Cl2, okay, Cl2, not Cl, yeah. Now 21 over 24, so, okay, again, okay, you can calculate 21 over 24, 7 over 8, so 0.875 mole of Cl2, okay. So now I want to calculate the mass, okay. How to calculate the mass? Number of moles equals to mass over mR, okay, not AR, mR for that molecule, okay. So you have 0.875, okay, the mass I want to find, Cl2, so 35.5 plus 35.5, 71, okay. So divide by 71, the mass is going to be 71 times 0.875. So I just need to times my answer with 71, and I will get, okay, the answer as 62.125, okay. So that's going to be gram, okay. So I will just use this, but normally I will use 3 significant figures, okay. You can just give your answer as 62.1 gram, okay. Answer must be in gram, okay. Next, okay, number 2. A student investigates a solid metal carbonate. The metal in the metal carbonate is represented by M. The equation for the reaction, okay, is given, okay, over here, okay. The student measures 0.189 gram of metal carbonate. So you are using, okay, the metal carbonate, okay, MCO3 is going to be 0.189 gram, and sets up the apparatus shown in the diagram. Remove the bung and quickly add the metal carbonate and measures the total volume of the gas collected, okay. So now state the volume of carbon dioxide collected, okay. How to find, okay, you see, yeah. So we need to actually measure from here to here, okay. So we know that this is going to be 100, okay. If this is 100, so of course this one is going to be 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100, okay. So this one should be after 50, yeah. So this should be, the longer one should be 55, okay. So this one is going to be 54, okay. So I know that this is going to be 54 cm cube, okay, 54 cm cube. Now calculate the number of moles of carbon dioxide collected. Number of moles of carbon dioxide. Okay, so so here, okay, they want the number of moles, and then they say 1 mole of any gas. Okay, they occupy this one, so it means that they want you to use this. Okay, instead. Okay, so volume, I want to convert into number of moles. Okay, they have already give you this hint. Now do remember 54 cm cube, you need to change into dm cube. Okay, how to change? Divide by 1000. So you will get 0.054 dm cube. And then use the same way that I taught you just now. 1 mole of any gas, they will have 24 dm cube. So 1 dm cube is 1 over 24 moles, and I am looking for 0.54. Okay, so times 0.054. So here also you need to times by 0.054, so we can get how many moles. Okay, so you just need to times, yeah, so 0.054 divided by 24 mole, yeah. So that one, okay, you can calculate, okay, use your calculator, okay, 0.054 divided by 24, and you will get 0.00225, okay. So I will just keep it as it is, okay, so 0.00225, okay. Now, use the equation, okay, to calculate the number of moles of metal carbonate used in the experiment. So first, okay, use the equation to calculate the number of moles. Okay, now they are asking us to use the equation. So let's use the equation, okay. So here, don't use this one yet, yeah, don't use this, okay. They say use the equation. So now, if you have carbon dioxide, you know 0.00225. So I just put 0.00225. Okay. Now, everyone should know this. Okay, the ratio 1, 2, 1, 1, 1. Terence, have a look. Yeah. So why we have this ratio? Okay, because of the number. Okay, in front. Okay, so we will use that number. Now, they want us to find the number of moles of metal carbonate. So metal carbonate is in 1 mole to metal carbonate is 1 mole. Ratio 1 to 1. So if you have ratio 1 to 1, okay, it means that the number of moles over here is also the same as the number of moles over here, 0.00225. Okay. So once I have that, so number of moles is going to be 0.00225. If you want working, so number of moles, okay, of carbon dioxide is the same as the number of moles of metal carbonate. Okay, so you can write down. So therefore equals to this number of moles. Okay, so this is going to be 0.00225. Okay, same. Use the information in the beginning of the question and your answer to calculate the mass of 1 mole of metal carbonate. Okay, so in this case, we want to use the information in the beginning of the question and our answer to calculate the mass of 1 mole of metal carbonate. So in this case, okay, they want us to calculate 1 mole of metal carbonate. Okay, so it means that, okay, the student, they measure 0.189 gram, okay, of metal carbonate, which is 0.189 gram is going to be 0.00225 mole. I hope you can understand this relationship. It means that just now we know that the number of moles of metal carbonate that we use is 0.00225. Okay, and then we know that we use this amount of mass. Okay, so it means that, okay, this 0.189 gram is for 0.00225 mole. So I'll just put it down over here. 0.189 gram is 0.00225 mole. Okay. Now I want to calculate. Okay, they say that calculate the mass of 1 mole. Okay, 1 mole. So 1 mole. Okay, how do I get 1 mole? Okay, so this value I divide by 0.00225 mole, I will get 1 mole. Okay, rather than putting mole. Okay, if you divide here, you will get 1, right? So if in an equation, if you divide on one side, you have to divide the same thing on the other side. Okay, so it means here I divide also. Okay, with 0.00225. Okay, so you will get for 1 mole, what is the number of gram? Okay, so that value, okay, we can calculate, which is going to be okay, so that's going to be 0.189 divided by 0.00225. That's going to give us the answer of 84. Okay, now I want everyone to look at the board. Yeah, please remember I didn't give you anything, so everyone should be looking at the board. So for 84, okay, the mass of 1 mole, the mass, yeah, so you cannot just put 84 only, it must be 84 gram. Okay, use the following, okay, to calculate the mass. Okay, use the following to and your answer to calculate the mass of 1 mole of metal carbonate. I think this is wrong, yeah, not mole. Okay, so it's going to be 84 gram. Okay, 84 gram. Now calculate, okay, the relative atomic mass of metal M. Okay, metal M. Now metal M is MCO3. Okay, you see MCO3. Okay, MCO3, and then we know the MR. Okay, the MR, how do we calculate MR? 1 mole has this amount of 84 gram. It means the MR is 84. Okay, 84. So the MR is 84. Okay, the MR of MCO3 is going to be 84. So how do we get that? So we can calculate. Okay, the AR of M plus carbon is 12. And then oxygen is 3 times 16 is 84. I can calculate what is M. Okay, how to calculate M? M equals to 84 minus 12 minus 3 times 16 is 48. Okay, so I will get, so this one is 84 minus 60, so it's going to be 24. The AR of metal M, 24. Okay. Now refer to the periodic table. What is the group and the period number of that metal M? Okay. The AR is 24. Okay. Let's find out which group and which period. 24. Okay. Not proton number, mass number. Yeah. So let's look for 24. Okay. 28, 27. 24. Can you see here? Okay, 24 is reflecting for magnesium. Okay, so magnesium, they want us to find out the group. Which group is this magnesium? Group 2. Okay, group 2. Period. Okay, so this is going to be period 1. Okay, period 2, period 3. Okay, where 1 because of helium, yeah. So here, period 3. Hold on, yeah. So from what I know, period 3 is this one. We don't count that as period 1. Hold on. No, correct. Period 3. Okay, period 3. This is period 4. Okay, so period 3. So 1, okay, 1, 2, 3. So group 2, period 3. So group 2, period 3. Okay, question number 3. The question is about elements in the periodic table. The table shows some properties of 5 elements B, C, D, E, and F. Okay, use only the elements shown in the table to answer this question. So cannot be from somewhere else. Only the elements. They didn't say you cannot repeat and so on. Okay, we will follow the instruction clearly. Now, state which 2 of these elements. Okay, 2 of these elements have covalent molecules. Okay, so covalent molecules. Okay, which one that have covalent molecules? So element covalent molecules. In order to be covalent, okay, covalent molecules, the melting point, okay, and boiling point will be very, very low. Okay, so if you look at here, consider to be high. The lowest is these 2. Okay, the lowest is these 2. And then generally, okay, covalent molecules, they do not conduct electricity. Okay, so but sometimes, okay, the solid ionic molecule also, they do not conduct electricity. So in this case, the reason why I select this one is covalent molecule is because of the melting point, low melting point. Okay, so I will write down, okay, low melting point, and then they say 2 reasons. Okay, another reason will be rather than looking at the electrical conductivity, you look at the density. Okay, the density may be lower. Okay, density will be lower, or you can just say do not conduct electricity. Yeah, I think better. Density lower. Okay, but this one also density is considered to be low as well. Okay, so maybe I'll just say they do not conduct electricity. Yeah, so element B and element F. Okay, reason number 1, low melting point. Reason number 2, do not conduct electricity. In supposed to be solid or liquid. Okay, so supposed to be, but in this case they only put for solid. Yeah, so it doesn't matter. Okay, as long they have do not conduct electricity, you will get the mark. Now diamond is a form of solid carbon. Okay, describe the structure and the bonding in diamond. Now diamond, okay, they are going to be the structure is going to be a giant, okay, giant covalent molecule. Okay, giant covalent molecule, and then the bonding, okay, which has, okay, covalent bonding. Carbon and carbon, they are bonded covalently. Okay, which has covalent bonding. So that's why, okay, diamond do not conduct electricity. But how about graphite? Can graphite conduct electricity? Yes, okay, because diamond, each carbon, they are bonded with 4 other carbon. So 4 valence electron, they are from group 4. 4 valence electron has been utilized or used completely to share to other carbons. But graphite, okay, they are arranged in layers. They are going to form hexagonal structure, and they have many layers. Okay, layers like sheets of paper. Yeah, so many layers. So each carbon, they are bonded to how many other carbon? They are bonded to 3. 1, 2, 3. So it means that each carbon, they will have 1 electron. one electron, free electron. So if they have one free electron, it means there is delocalized electron. Okay, the electrons can still conduct electricity within graphite. Okay, that's the reason. But when we look at diamond, on the other hand, each diamond is going to be, each carbon, they are bonded to 4 other atoms. Okay, like for example, 1. Okay, so you bonded 1, 2, 3, 4. Okay, so therefore, all these are used up. So no electron, no electron, no electron, no electron. In order to conduct electricity, you must have maybe C of delocalized electron, or you must have free moving ions. Okay, free moving ions. In this case, both of them, no, it's not there. Okay, so state, state why diamond is used for cutting tools, because diamond is very hard. Okay, hard and strong. Okay, to be exact, diamond, okay, they quite hard. Okay, they are strong, so they don't break easily. Okay, but do go and check in internet. Yeah, can diamond, okay, be broken? Okay, actually diamond, they say diamond can be used to cut everything. Okay, and in order to cut another diamond, they use another diamond also. Okay, but you can check in online internet, diamond can be broken. Okay, easily. Okay, so there is a video. Yeah, so even though they say it's strong, okay, strong things can be also be broken. Yeah. Now name one another form of solid carbon and draw its structure. Solid carbon. Yeah, so just now it's graphite. Okay, we have graphite. Okay, I think 2 things we learned, diamond and graphite. Okay, so they say form of solid carbon. So this one, although it's not 100% solid, okay, sometimes it can be used as lubricant, yeah, and so on. So this one we just say, okay, name, so graphite. Okay, and then draw its structure. Okay, how to draw the structure? Just now I draw for you already. So you draw like this. Okay, 1. So you draw. So let's say this is 1. Okay, so you can draw another one, another layer. Okay, layer 1, layer 2. Okay, so they have weak bonds between the layers and very strong bond within the layers. Okay, so if you compare, okay, the melting point of diamond is very high. Okay, but graphite also melting point should be high, but lower than diamond. Okay, why? Because the attraction between the layers is weak, and because of this attraction that is weak, graphites, they are also used, okay, as lubricants. Because why? The layers, okay, they can slide on top of each other, okay, because of weak bonding. So lubricants, okay, they use as lubricants or oils, okay, to reduce friction, okay, of moving parts. Okay, so like engines and so on. Okay, so gears and so on. Okay, so that's going to be the answer for that. Now, lithium is an element in group 1 of the periodic table. Write a balanced chemical equation, okay, of lithium reacting with oxygen gas. Okay, lithium reacting with oxygen gas to form lithium oxide. Lithium group 1, Li plus, oxygen 2 minus. Okay, so this one must times by 2, okay, to get 2 plus. So you will get Li2O. Okay, so now if you want to balance, okay, 2, okay, and then half, okay, to get 1O. But in chemistry we don't use half, okay, we times everything by 2, you get 4Li plus O2, okay, half times 2 is 1, okay, to give you 2Li2O. So when I write down, okay, so I will write down 4Li plus O2 to give 2Li2O, and then Li is metal, so solid. This is gas, okay. So this one to form lithium oxide, okay, solid with gas. Of course, you don't get suddenly liquid or aqueous, so it's going to be solid also. Okay. Now, state whether lithium oxide is a basic oxide or acidic oxide. Next week is the exam related to this. Is it basic oxide or acidic oxide? How to identify? Metal oxides, basic oxide. Non-metal oxides, acidic oxides. So in this case, this is metal oxide. Therefore, they are going to be basic oxide. Okay, so basic oxide. Okay, give a reason for this. Okay, there might be many reasons. Okay, but you can say metal oxide. Okay, metal oxides. Okay, forms acidic oxide which basic oxide. Okay, they form basic oxides which gives a solution of pH higher than 7 when dissolved with water. Okay, so I think that will be complete. Okay, why we call it as acidic oxide or basic oxide. Okay, when you add water, pH, okay, basic oxide, pH is going to be more than 7. Okay. Now, halogens are a group of elements with diatomic molecules. They form ionic compounds with metal. Okay, in the equation below, chlorine gas reacts with aqueous solution of lithium bromide. Okay, what is the color change that will be observed in the solution? Okay, so from what color, okay, to what color? Yeah. So in this case, lithium bromide, you see the solution, yeah. In this case, this is gas. Okay, they are looking for the solution. Okay, the solution. Lithium bromide is colorless. Okay, lithium bromide is colorless. How do I know? Okay, this one like something lithium bromide means this is group 1 bromine. So it means sodium bromide, sodium chloride is also going to be colorless. You should know this. Yeah. So they are going to be the same. Yeah. So lithium bromide is colorless. And then, okay, you are going to get this lithium chloride, okay, and then you have Br2. So in this case, okay, this is also colorless, okay, but bromine, okay, bromine gas, okay, they can, since this one is a aqueous solution, lithium chloride, okay, bromine, okay, gas, some of the bromine gas, they can mix with water. Okay, they can give you bromine solution. Bromine solution is going to be brown or orange in color. Okay, so now the entire solution is not going to be colorless. It's going to be that kind of a brown or orange. Okay, so it means the color change that we will observe, okay, is going to be from colorless to orange or colorless to brown. Okay, so you can choose which one you want. Okay, colorless to orange. Now, suggest a reason, okay, why bromine does not react with lithium chloride. Okay, why there is no reaction. Okay, why? Okay, in this case, okay, these are the couple, husband and wife. Okay, so we know Cl, Br, and I, Cbi. Yeah. So we know that, okay, the one on top, okay, can displace the one below. So if you look at Br is below Cl. Okay, what does it mean? Okay, Cl is already very handsome or very pretty, and this is an ugly girl. Okay, so when they try to separate the couple, most likely that will not happen. Yeah, so it means that, okay, you just say Br2 is less, okay, reactive, okay, compared to chlorine. Therefore, Br2 is not able to displace, okay, Cl from LiCl. Full stop. Okay. Now, so we are left with question number 4. Okay, and let me check first. Okay, for question number 4, ammonia and ethanoic acid are weak base and weak acid respectively. Define the term weak base. So a weak base, okay, is going to be a base that, okay, is a base that incompletely, okay, or partially dissociate, okay, that partially dissociate in the solution or with the presence of water. Now, a few drops of universal indicator is added to dilute ethanoic acid solution in conical flask. Okay, so that's going to be, if you add into the conical flask that contains acid, okay, basically the universal indicator will be red in color, and then aqueous solution of ammonia is added to the flask from the burette until the indicator changes color. What is the color change of the universal indicator at the end point? So basically at the end point, okay, when we are looking into acid and base reaction, okay, we are looking into a neutral solution. So basically the color change should be, okay, initially it is inside the acid, so the color changes from red, okay, to become green. Okay, so green is the time that is the part that it become neutral. Okay, so red, green, then alkali is going to be blue. Yeah, so in this case at end point, at the point that it is completely free or complete reaction, so it's red to green. Yeah, now next, a student graph, okay, of how the pH changes when aqueous ammonia is added slowly to dilute ethanoic acid is shown below. Okay, so you can see the pH, okay, generally increases, okay, because inside the conical flask they have actually put dilute ethanoic acid, and then they are going to put the ammonia slowly, okay, from the burette, and then generally the pH is increasing. Okay, so deduce the following: the pH of the dilute ethanoic acid, okay, before, okay, the pH of the dilute ethanoic acid before the addition of aqueous ammonia. So before the addition of aqueous ammonia, definitely the pH is over here. Okay, so 0 volume of ammonia. So that's going to be, if you look at here, this is 5. Okay, so there are 5 boxes over here, okay, small boxes, so this should be 4.2, okay, 4.4, 4.6, 4.8 and 5, so this will be 4.2. Now the volume of aqueous ammonia added when the pH is neutral. When the pH is neutral, we are talking at pH 7. Okay, so if I bring this over here, okay, and then if we bring this over here, okay, so we can see, okay, this is the volume of aqueous ammonia when the pH is neutral. Okay, the volume is, okay, this is going to be 25, so this is going to be 21, 22, 23. Okay, so this is 23 cm cube. Okay, so 23 cm cube. Now 0.05 mole per dm cube of ammonia solution reacts with 0.10 mole per dm cube of ethanoic acid. Okay, and then we have the equation over here. Okay, using the volume in C2. Okay, so let's look at volume in C2. Okay, this is C, so volume of the C2 is 23 cm cube. Okay, 23 cm cube. Okay, is the volume of ammonia. Okay, so volume is 23 cm cube. So using the volume of C2, okay, calculate the number of moles of ammonia. Okay, so we know that this volume you can change it into dm cube, divide by 1000. Okay, so you will have 0.023 dm cube. So if I want to find out the number of moles, number of moles equals to, in this case, we know concentration. Concentration is going to be number of moles divided by volume in dm cube. So number of moles we want to find. So let's actually put it down. So number of moles we want to find. Concentration is already given 0.05. Volume must be in dm cube, so divide by 0.023. We already changed it into dm cube. So we want to find the number of moles. Number of moles is 0.05 times 0.023. So what we will get, so let's actually look at, let's calculate. So 0.05 times 0.023, and we will get, the answer is going to be 0.00115. So this is going to be, we want to find the mole, so mole. Now next is going to be, once we have this, so this one is the number of moles, of ammonia. So we know according to the equation 1 mole, according to coefficients in front, 1 mole reacting with 1 mole to give you 1 mole of this. So if I have 0.00115 moles of ammonia, we can calculate the number of mole of ethanoic acid, because 1 to 1. Therefore, the number of moles of ethanoic acid is 0.00115. It's the same. So this is going to be 0.00115. Mole. Now calculate the volume of ethanoic acid required to neutralize this 0.05 mole per dm cube of ammonia. So we know from ethanoic acid, if you need 0.00115 mole, and we know ethanoic acid is given, this is the concentration, so we have 0.10 mole per dm cube. We want to calculate the volume. So how to do? Concentration equals to number of moles divided by volume in dm cube. So concentration is 0.10. Number of moles is going to be 0.00115. Volume is the one that we want to find. So what is volume? Volume is going to be 0.00115 divided by 0.10. You move this one side, you move here one part, it's going to be 0.0115 dm cube, and you can change it into cm cube. You times by 1000, so that's going to be 1 2 3. So 11.5 cm cube. So you will get this as the answer. So you can leave it into the in dm cube, or you can change it into cm cubes. But since the question were dealing with cm cube, you can see earlier, they have given the answer in cm cube, or you have given the answer in cm cube, So here we just keep it as cm cube. Okay, 11.5, don't forget the unit, very important, cm cube. Okay, now next, limestone rock is mainly calcium carbonate. The limestone cycle is shown. Each step is numbered, so we have total of 4 steps over here. So we have limestone, okay, which is sodium calcium carbonate, CaCO3. Then you heat up, okay, you will get lime. Okay, do remember what is lime. Okay, if you don't remember what is lime also, it's okay. Calcium carbonate, when you heat up, they will break down into calcium oxide plus carbon dioxide. So when they say lime, this is lime. Yeah, so CaCO, okay, but we don't know what they're asking. Yeah, so let's actually keep it at the side first. CaO, that's lime. Okay, and then step 2, okay, you add limited water, okay, and you will get calcium hydroxide. Yes, okay, when you have calcium oxide plus water, you are going to get calcium hydroxide. Okay, so this one, okay, you have 2 oxygen, hydrogen, everything is balanced. Yeah, now after you have that slaked lime, okay, we are going to add excess water. Okay, that calcium hydroxide in solid form, they are going to become calcium hydroxide aqueous. Okay, so that's going to be lime water. Okay, so lime water is going to be, okay, we can use them to check for carbon dioxide, testing for carbon dioxide. So when you, let's say for example, lime water reacting with carbon dioxide, what will happen? Yeah, so we will get the white precipitate, or the solution will become cloudy. Okay, why they become cloudy? Because there is a formation of calcium carbonate. Yeah, so that is why. Okay, so when you have calcium hydroxide, okay, when you react, okay, with carbon dioxide, we are going to get calcium carbonate. Okay, and calcium carbonate, and of course you will get water. Okay, so let's see what they want. Okay, complete the box to give the chemical name and the formula of the lime. What is the formula? Okay, CaO. What is the chemical name? Chemical name, calcium carbonate. So CaO is calcium oxide. Now, which step involve physical change? Okay, so you see from physical change, okay, in this case, okay, we know calcium carbonate to change into calcium oxide. Yeah, this is a chemical change. Okay, so that is going to be from CaCO3 become CaO. Okay, but if you look over here, okay, calcium hydroxide, okay, it's changing from solid to become aqueous. Okay, but here, okay, calcium hydroxide to calcium carbonate is a chemical change over here, because CaOH2 then to become CaCO3. So in this case, the step that involve physical change is going to be step number 3. Okay, because physical change, it can happen vice versa. So after we get from slaked lime, you can get lime water. Lime water you can change back to slaked lime by removing the water. Yeah. So what type of reaction is step number 1? Okay, step number 1, because it is breaking down, okay, into, okay, one compound is breaking down into smaller parts. Yeah, so this one we call it decomposition. Okay, and because there's heat, we call it as thermal decomposition. Okay, decomposition is breaking down. Now, suggest how step 2 could be reversed. Okay, how do we reverse this step? Okay, if you add limited water, okay, so if you want to get, okay, back calcium oxide, okay, how do we change calcium hydroxide to become calcium oxide? Okay, so we need to remove the water. Okay, so how do we remove the water, calcium hydroxide to become calcium oxide? So probably by evaporation. Okay, but we can check the marking key first. Hold on. Okay, let's check the marking key. Okay, if you want to thermal decomposition, heating, yeah, so the answer is heating. So basically we want to remove, okay, we want to remove the water, okay, so we want to remove the water. Step 2, okay, so we need to change the calcium hydroxide to become calcium oxide. Okay, so we just need to, previously you add limited water, so you need to remove the water, so you just need to heating. Now write a chemical equation for step number 4. Okay, step number 4, okay, we want to write the chemical equation. So calcium hydroxide, okay, calcium hydroxide, when you add carbon dioxide, you are going to get calcium carbonate. Okay, so if you have calcium carbonate, okay, the remaining, okay, so calcium carbonate, so the remaining will be water. Okay, so let's actually see how to balance here. So oxygen is 4, okay, left hand side is also 4, carbon is 1, okay, hydrogen is 2, left also 2, so it's already balanced. So we'll just take this one, copy, paste it over here. Okay, so calcium hydroxide, okay, is going to be, okay, in this case they are aqueous, so let's say we take aqueous, gas, okay, solid, okay, liquid. Why solid calcium carbonate? Because calcium carbonate is the white precipitate, okay, it's solid, okay, over here. So this one is aqueous, calcium hydroxide is aqueous. Now explain why step 4 is a neutralization reaction. So why step 4 is a neutralization reaction? Okay, a neutralization reaction is going to be any reaction that produces water. Okay, so explain why step 4 is neutralization reaction. Okay, refer to the substances reacting in the answer. Yeah, so okay, in this case the substances are reacting, like from calcium hydroxide, okay, reacting with carbon dioxide to give you water. Okay, so in this case, okay, it's going to be like acid base reaction. Okay, so acid base reaction, okay, in this case carbon dioxide is going to be like a acid, okay, and then calcium hydroxide is a base, okay, and then they are going to give you this H2O. Okay, so let's actually check, okay, the marking key, what they have written. So you see carbon dioxide is acidic, calcium hydroxide is base, okay, that's why it's going to be neutralization. Okay, so carbon dioxide is acidic and calcium hydroxide is basic, and they react to give water molecule. Now dolomite is similar rock to limestone, okay, so it contains magnesium carbonate. Okay, so if it is similar, the reaction is almost similar. Okay, write the ionic equation for the reaction above. Now when we look into ionic equation, do remember solid, they cannot break down, okay, into individual ions, so it must be like this. And then this one aqueous, yes, you can change it into 2H plus 2NO3 minus, okay, and then to give you aqueous, so Mg2 plus 2NO3 minus, Water liquid cannot be broken down. Carbon dioxide molecule cannot be broken down. So we will see which one is the spectator ion over here. Spectator ion, okay, will be in the left hand side and right hand side. Yeah, so if you look over here, the 2NO3 is going to be the spectator ion. Okay, so we can remove that. Okay, so in this case, the ionic equation is magnesium carbonate, okay, plus 2H plus to give Mg2 plus H2O plus carbon dioxide. Okay, and if you want to write down solid, aqueous, liquid, gas. Okay, chalk is almost pure calcium carbonate. Okay, so 20 gram of chalk, so I'll just use 20 gram of chalk was reacted with excess dilute nitric acid. So it means all the 20 grams is completely reacting. Okay, so this one is excess. So if we want to put in the equation, is 1 mole, 2 moles, 1, 1, 1. Now 4,560 cm cube. Okay, so this one 4560 cm cube was collected. Now calculate the mass of pure calcium carbonate that is used in this reaction. Okay, so we need to calculate the mass of pure calcium carbonate. So first of all, okay, we know that now 20 gram is not 100% pure. Yeah, so here we will use this value. Okay, so we need to find the number of moles. Okay, how to find number of moles? Okay, because related to gas, we know 1 mole of any gas occupies 24 dm cube. Okay, so in this case, if you have cm cube, I can change it into dm cube by dividing by 1000. So I'll get 4.56 dm cube. So 1 dm cube is 1 divided by 24, and I'm looking for 4.56 dm cube. So you times with 4.56 left and right. So what I'm going to get, how many moles? Okay, is going to be 4.56 divided by 24. Okay, moles. Okay, of, okay, do remember, still carbon dioxide. So here, okay, I will just use the calculator. 4.56 divided by 24. You will get 0.19. Okay, this 0.19, okay, we need to check again. This is going to be 0.19 mole, and we are looking for calcium carbonate. So if you have 0.19, okay, we are going to get 1 mole to 1 mole. So we must have 0.19 moles of calcium carbonate also. Okay, but let's calculate the mass. Okay, number of moles of calcium carbonate, okay, is going to be 0.19. The mass, okay, number of moles, okay, of calcium carbonate is going to be mass of calcium carbonate divided by, okay, mR. So the mass, okay, number of moles, okay, sorry, we know the number of moles, 0.19. Mass of calcium carbonate, okay, divided by mR. So calcium, okay, all this you can check over here. Calcium is going to be 40. Carbon is going to be 12. Oxygen is going to be 4 times 16, so it's going to be 0.19. Okay, this one, number of moles, is this solved already? Let me check again. 0.19 0.19 number of moles. Okay, and then I need to find the mass. Did I find the mass? Okay, hold on, yeah, still here. So if you have number of moles, okay, oh, I'm writing in the wrong place then. Okay, so we are still doing that. Okay, this one make it smaller. This one I'll try to make it smaller also. Okay, so we want to find the mass here. So again, okay, mass divided by, that's 52, okay, 64, 6, 116. 116, mass is going to be 0.19 times 116. So let's calculate this. 0.19 times 116. 22.04. So the answer is 22.04 gram. Now, so left with, okay, we need to calculate the percentage of purity of chalk, okay, because just now we used 20 grams of chalk, okay, was reacted with excess dilute nitric acid. Okay, so we need to actually when we did this, okay, chalk is almost pure calcium carbonate. 20 gram was reacted with the excess. Okay, and then you collect 4560 cm cube of calcium carbon dioxide. Okay, so what we did, okay, we have changed, okay, whatever value that we have, okay, so which is going to be the 4560, okay, we change it into dm cube, so it becomes 4.56, okay, and then we divide by 24, okay, we get 0.19 number of moles, okay, so 1 to 1, okay, 0.19 mole over there for calcium carbonate. Okay, so we know number of moles equals to mass over mr. Okay, we put the mass mr, calcium carbonate 40 plus 12, okay, plus yeah, that is the mistake here. Okay, so this one is wrong. Okay, so this one is 3 instead of 4. 3 times 16. So this should be, okay, 52 plus 48. Okay, so I will get 100. Okay, so this one is mistake, 100. So times 100. Okay, so I will get when I times 100, okay, 1, 2, so 19 gram. So once we have 19 grams, so we want to actually find the percentage of purity. So this one is wrong, so 19 gram. Okay, so the pure compound, okay, the pure compound is going to be 19 gram, okay, divided by, okay, the total mass, which is going to be 20 gram, okay, times 100%. Okay, that's going to be percentage of purity. Okay, or basically the mass of pure compound divided by total mass times 100%. So this one, if you calculate 19 divided by 20, 19 divided by 20, we will get 0.95 then times 100, so 95%. Okay, so 95%. That's the percentage of purity of the chalk. Okay, so we can check also. Okay,